Hello everyone and welcome back. So I have this very basic scene with a box, a Voronoi fracture, and I'm gonna hit play. This is what we have. Great. So the idea is we wanna upres this geometry and do the edge displacement in Houdini first and get everything to work here. And once we do that, we're going to be able to replicate it. Now I'm going to use Houdini SOP's noise, and later when we get to the real example, I'm going to show, maybe I'll use this one to continue the explanation. We're going to show how to do it with Arnold, which doesn't have the noise nodes available in SOPs. So for this one, we're going to first focus on getting this working in Houdini to make sure that we fully understand everything. So we have this this geometry, and we want to displace it and add resolution. So the first thing we need to divide it. We need more details. Okay, so I'm gonna put down a divide node, and I'm gonna subdivide it quite a bit. That's very low. Let's go 0.05. Okay, so we have the geometry. I don't need to divide it. We could. So we have increased the resolution of our mesh. Cool. So if we transform this, transform pieces, I'm going to use the points, and then this, it's going to work perfectly fine. No problem. We didn't change anything. Now let's take a look. What do we need? If I display the normals, we don't have normals, so let's create them. If I display the normal, you can see that each face has a vector pointing upward. Okay, so this is great because what we can do is we can compute a few things that will allow us to find a vector that is aligned along the surface, okay, that always follow the topology of the mesh no matter what it is. So if I create a point VOP and dive inside and do a cross product between an up vector and the normals, and then plug the normals again, I want to modify them. So if we do that, we get a vector, okay, and you can see that it's aligned, it's flat along the surface. So let's go up. I want to delete the interior faces and only focus on the outside faces. So outside, just to make it easier to look at. Okay, so we have normals, and if we do the cross product, you can see we're getting aligned vectors. Let's see. Yeah, we're getting vectors aligned along the surface. So we have this, but we need something else. Like I said, with the draw, we need two vectors. We need X, something to push along this way, and something along this way. So we need another one. So we're gonna call this X. I'm gonna create a null. I'm gonna call this X, and I'm gonna copy this node and compute the cross product between X and normals again. So this is our X. The normal is the original vector, which is this. If we take the two and compute the cross product, we're gonna get a vector perpendicular to both of them. So let's say we have this is X. Okay, we have the normals, which is pointing up like this. If we compute the cross product, it's gonna create a plane, a virtual plane, and then give us the perpendicular vector along that plane. And this is going to be our y-axis. Okay, so we need the x and y, and the z we're not gonna use because we don't want to push the points along the normals. So I'm gonna copy this and call it y. Okay, and let's take a look at this y, and you can see it's pointing in a different direction. And I'm gonna export this as 3 separate vectors. So bind export, bind export. And we're gonna export the, we're gonna leave the n, we're not gonna change. So it's gonna be the same, and then we're gonna call this x, and it's a vector. And then we're going to export y as well. So let's go up, and I wanna visualize all these vectors. I'm gonna create a visualize node. And the first thing is, we're going to change it to markers and point trail, vector trail or vectors. And we want to display x, and let's reduce the length. So that's our x vector. I'm going to copy this, and I'm going to call this y, and I'm going to use a different color. Green, blue, red, and we have blue. And we see that we have, especially let me fuse this. I'm gonna fuse the mesh so I don't get the in between points. So you can see we have x, y vector, and the z vector. We're not gonna push along the z because that's gonna disturb the mesh. We only wanna push along the x and y. So let's dive inside. Let's go back here, and let's create a noise pattern. And we're going to use the current point position. And let's view this. So I'm going to increase the frequency, something like this. And we're going to use let's do it in a separate node so that everything is clean. So this is called vector prep. I'm going to create another point VOP. Yeah, this is better because we're going to see why in a bit. So I'm going to create a noise pattern, and let's visualize this. Increase the frequency to 10, 10, and then we want to import those x and y. So our x vector and the y vector, and we're going to multiply each one of them. So I'm going to multiply the x with this noise, and let's invert it because this is a vector and this is float, and I'm going to add this result to the point position. And let's disable this and look at the result. Okay, so you can see the geometry is getting pushed along that vector. So let me disable this. Let me lower the amplitude, and you can see it's getting pushed along a nice vector. It's not random. And let me disable the fuse. So if we do this, you can see we're getting the points. I'm gonna put back the fuse for now, just so that we get nicer result. We'll fix it in a bit. So you can see we're pushing the points and they are not changing too much. These issues we're gonna fix in the next video, but for now you can see that the overall silhouette of the geometry didn't change. Yet we have fractures inside, and we're pushing the points. Now this is along the x. I want to push it a bit along the y as well because we want more randomization. This is going to be very uniform. So I'm going to use a multiply node, same thing. I'm going to multiply the y with the noise, and we're going to add it as well. So now we're pushing it along two vectors, and if I disable, you can see we're getting more interesting details. Now the only problem is it's also affecting everything here. Okay, we don't want that. So we need a way to mask our geometry. We need a way to make sure that we don't affect the main silhouette, except these, which we're going to fix in a bit. This is something we have to mask. So where can we find that information? Well, if we go back to the original pardon me, if we go back to the original box, we see that we only have enough wires to describe the silhouette. So if I put down a divide node and sorry, not divide node. If we put down a carve node and set this to 0, you will see that we have wires representing that silhouette. But right now it only has few points, so we need to resample this geometry because I need more points. And what we can do is we can go back here to this, and let's increase the resolution for now. 25 to 25. Okay. What we can do now is we can use this as a mask, and I'm going to put down a color node, and this is going to be red, and this is going to be white, sorry, black. Attribute transfer, and I want to transfer the color, and if I reduce this, we can create a nice mask. We can soften it like this, and I'm going to displace this instead, or plug this in, and then if we dive inside, I'm going to do a mix, and I want to mix between the current position and the new position, and I'm going to mask everything with this red information. So vector, I'm going to pick the red channel, and then if we plug this in, it's inverted, so I'm going to swap these two, so this and this, and now we're displacing everything except the boundaries. Okay, now obviously if we displace it too much, it's going to still go beyond, because that point is coming from very far away. And what we can do is we can tweak, we can lower the amplitude, tweak our noise, make sure that everything is stays in a reasonable region. Okay, so that's our mask, and let's lower the frequency, maybe 555. Okay, and let's go up and do an exploded view. Cool. So we started with this geometry, and now it's this, and you can see we have a lot more details now in the edges, but currently we're only working on the outside faces. We need to add the inside faces as well. So if I go back here and disable this node and take a look, it's working on the inside faces as well, but it's not perfect. It's gonna overlap. Okay, it's not ideal yet. And the reason for that is because, I'll explain it. The reason for that, let me explode view this one. So if we look at this, for example, piece, this surface is going to have normals pointing this way and this way, or it's going to have normals pointing this way, and then our x is going to be like this, our y is going to be like this. But this side is going to have its own, so its normal is going to push along this vector, and then the x and y are going to be pointing, let's say, this and this. And that means that this face is going to push this way, and this face is going to push this way. So they're going to intersect. And what we need to do is we need to tell all this that it needs to respect whatever is happening on this face. Okay, so the inside needs to respect what's happening above. And the easiest way to do that is this. So I'm going to isolate the outside and set up my vectors, and then if I copy this and say delete non-selected, okay, this doesn't have information at all. I don't want this geometry to have its own data. So what I'm going to do is I'm going to put down a transfer node, and I'm going to transfer the x and y vector, which are here only, I'm gonna transfer them to this. I need to flip it. So you see we have x and y. I'm not gonna change anything. I'm just simply gonna merge both. And I'm gonna use it here. And if we take a look, it should work. So the idea is we're going to take and prep the geometry, the settings here, the attributes that we need. We're going to transfer them onto this geometry and then merge the two together. And what it means is this geometry is going to inherit, I need this. So what it means is this geometry is going to inherit the x and y of this, and it's not going to have one on its own. So let's go back. And now if we do exploded view, I am not so sure why it is doing this. Okay. So this is our inside faces. This is our outside faces. Inside faces. Attribute transfer. This from this. I don't need anything else. I'm going to transfer x and y. Then if we merge both, it works. We do this. It's good. And then if we look now, it should work perfectly. Oh, I know why. The exploded view was probably glitching. That's all. This is correct. And now if we look closer, this inside is no longer going in a different direction. It's following exactly the top. So see here, this part is blending exactly. Now if I disable, if I plug this, or let's do this. So this is, we're generating the normals on the entire mesh. If I plug this in like this, see, this geometry is going all over the place. And that's not great because we wanted it to be perfect. So if we dive back and play with the noise now and increase, we will see everything following and moving along the same direction. Okay, so that's how we're going to do it. In a nutshell, this is the process. But now we are only displacing it in this space. And if I use a transform node and plug this in, so this is our displaced geometry. And if we view it and hit play, it should work. Name attribute. What changed? Oh, because of the fuse. So I'm going to turn that off. And now if we take a look, go back, we'll fix it in a bit. But basically, if we play through, we will see that our geometry is high res now. Great. Now the problem is, this is not how we're going to do it at render time. We're going to still be transforming the original mesh, which is this. So this is what we will provide to the render. And if we do that, that means that this displacement is going to happen after. So let me copy this, paste it here. I'm going to re-explain this again one more time in the next video because I think it's very important. Now, if we do this, this is what we will pass to the render without the upres, but let's say for now it's like this. If we do the displacement after, check. Why is it not working? Okay, so let's say we're going to displace everything. The color was not working. So okay, so this is our geometry. It's original here, and then we transform the first frame, let's say it's fine, and then if we play through, we will see that the surface is going to change over time. Okay, so the vector that was used to displace this normal is no longer, you see it is no longer applicable. And that's something we have to fix, because we cannot have the normals change or be invalid after the first frame. So we need to fix it at this level. And when we pass everything to the render, it needs to be usable, so that doesn't matter what the orientation of the geometry is going to be perfect. So we'll do that. I'm going to re-explain this again once I fix a few things, and then we'll continue fixing this problem. Thank you guys for watching, and see you in a bit.